Okay, so in part B, we need to use an iterative formula based on the equation we have come up in part A to find the value of A correct to three significant figures. We need to start with a value of 2, and we need to state each solution to five significant figures. So we have found that A is equal to 1/2 times e to the 7 over 5 times 2a plus 1 minus 1/2, all under the cube root. So in fact, we can see that we were not able to solve for A alone. So we cannot find a explicit formula for A. This is only implicit. However, what we can do is choose an initial value of A. Based on this formula, calculate the actual value of A, and we can compare the initially chosen and the calculated A's. And what we want is that these two be very close to each other, because then we have found a solution. We're told we need to start with a initial case of 2. So that means that what we have to do is take 2, plug it in. So when the first term of A is 2, and from this we just have to plug this in. So this is just going to be the cube root of 1/2 e to the 7 over 5, and then 2 times 2 is 4, so that's going to be times 5 minus 1/2. And if we plug this in, then this is going to be 2.1177. So we see that these two numbers are not really the same. What we want is that these two numbers be very close. However, this is going to be closer to the real value of A. So what we can do is now take the next value of A as 2.1177 and plug this in and see what we get. If we plug this in, then we get that this is going to be 2.1651. And what we can do is plug this in now and see if we get any closer. So if we plug this in into our calculator, again just plugging it into this formula, then what we will get is that this is equal to 2.1759. And now we can use this one. So we can plug this in, and we're going to keep getting closer and closer to the real value of A. If we plug this in, we get 1.1778. So you can see that indeed the initially chosen now and the calculated value of A are very close to each other. So let's plug this in now. So 2.1778, and this is going to be resulting in 2.1781. And well, we have to get the final value of A correct to three significant figures. So basically we can see that the last two terms here are already very close to each other. So we can say that the value of A is going to be approximately, 2.18. This is three significant figures, and we can see that both of these last two terms will round to 2.18. If we continue going, it's probably going to be somewhere around this value over here.